everyone, we're going to verify trig identities with complex rational. We're only doing one here. Most of my students have a hard time with this one. So the first thing I'm going to do is write this in terms of sine and cosine, and I'm going to go ahead and work on the left side of the equation. Okay, so I just broke down tan and cotan. Now I'm going to find the common denominator, and my common denominator in both of these is cosine. So there's the complex part. And you're going to put this in fraction form and cross here. So you get sine squared times cosine. I always forget to put my angles. Alright, minus sine. And then on this one, it's going to be cosine squared times cosine minus sine. Oops. Did y'all notice I wrote this wrong? Alright, sorry. So this is actually cosine of theta over sine of theta. So this is sine of theta. So this is sine of theta. Sorry about that. So sine of theta minus cosine. Alright, now the next step we're going to do is go ahead and factor out sine from the numerator at the top. And you're going to get sine theta cosine of theta minus 1 over cosine. And for the denominator, we're going to factor out cosine. And there you're going to get cosine theta sine of theta minus 1 over sine. Now what you should notice here are these two are the same, because all I have to do is switch the sine and the cosine. But I'm going to go ahead and on the next slide flip this. So remember, when you divide, it's the same as multiplying if you flip it. So I'm going to go ahead and write it the long way real quick. We have sine theta cosine theta minus 1 over cosine divided by cosine theta sine theta minus 1 over sine of theta. Now remember, all you have to do is change that to a multiply, and then you flip those two. So I'm going to write it again, sine of theta cosine theta minus 1 over cosine. Now flip it, change that to a multiply. You write sine of theta over cosine theta sine theta minus 1. Now, these two cancel, and you're going to get sine squared theta, won't multiply across, over cosine squared of theta, and that equals tan squared of theta. And that's our desired result. Thank you. Have a nice day. Bye-bye.